Hello, we are Min and Kenny, and welcome to our project where we used GANs to generate landscapes. I think landscapes can be inspiring, with the way trees meet water and how mountains look against the sky. We wanted to see whether deep learning models could generate novel and realistic looking landscapes. We considered several types of models, but after the GAN lectures, we became interested in training models against each other, so we decided to focus on the DC GAN by Radford et al. For training, we chose the landscape pictures dataset by Arnaud58 on Kaggle. We suspected that training on full-size images would be infeasible, so we pre-processed the data by first cropping down to 512 by 512, and then resized into three datasets of sizes 64, 128, and 256.
The DC-GAN consists of 4 transpose convolutional layers, with their pooling replaced by threaded convolution in the discriminator and fractional threaded convolutions in the generator. It also uses batch normalization layers and excludes connected hidden layers. For activation function, it uses a combination of 10H, ReLU, and Leaky ReLU. For our experiments, we initially re-implemented DC-GAN in PyTorch to work for 64 by 64 landscape images. Then we extend to build two extra architecture, DC-GAN 128 and DC-GAN 256, with extra convolutional layer along with batch norm and activation functions to work with 128 by 28 and 256 by 256 images. We will use binary cross entropy loss and atom optimizers as similar to the original implementation. Additionally, we will also feed part of the LHQ256 dataset to a pre-trained style GAN version 3 to compare the results.
For all of our training, we used Min's NVIDIA GPU. We trained our first DC GAN for 2000 epochs and trained our DC GAN 128 for 1000 epochs. We also tried to train our DC GAN 256, but unfortunately the CUDA ran out of memory. Moving on to the loss plots, across both models we see that generator and discriminator losses peak at around the same levels, but the loss fluctuates less overall for the DC GAN 128, and this could be due to the extra layer in the model that makes training more stable. Before looking at the images, it's worth noting that we're comparing different models, datasets, and training times, so our project is less about doing a rigorous comparison and more about exploring how different GANs can generate better and better looking landscapes. For our 64 by 64 images, we see that the landscape features have started to take shape, but the images are still fairly blurry. For the 128 by 128 images, these tend to be a little sharper. Additionally, we see that a few archetypes have started to emerge. Some images look like beaches with blue-gray skies, some sand, and some mountains in the back. We also see another archetype with green splotches everywhere. These compositions are more complex, which could explain why the images still aren't very realistic. Finally, looking at the results from the style GAN, we see that larger networks and longer training times really do produce better results. And that's pretty much the takeaway for this project. If we were to continue, we'd like to train our DC GANs on the full LHQ dataset for many epochs and see if those results can be competitive with the style GAN. With that, here are our references, and we hope you enjoy our website.